This is Lucas Bennett, and this is my lab number 9. So today we'll be studying a mass and spring system, and also the Earth is in the system, where the spring is actually oscillating in two different directions at once. It's oscillating in the X direction and the Y direction, and we'll see that they do not line up exactly. So in Tracker, I set up, this is my positive X-axis, my positive Y-axis, and everything else correspondingly. I set this equal to 0.7 meters, and then I've set the center of the mass equal just to be the center of this mass. So when you play the video, pay attention to how this mass is not oscillating in the X direction, or the Y direction and the X direction, in the same rate. So when it changes direction in the Y direction, it doesn't necessarily change direction in the X direction. So that'll be important later on. So what's important here is that we basically summed up all of our energies, spring potential, gravitational potential, kinetic energy, and they all equaled the energy total. And we'll see that they all cancel out and actually equal 0, because this is the system being the mass, the mass, the spring, and the Earth. Since no work is being done on the system, the work is actually, well, the total energy, which is equal to the work, is 0. So there's energies going on inside the system, but they're all going to cancel out because there's no energy being put into the system. So conservation of energy, delta E has to equal 0. So from Tracker, I imported the X and Y data into a spreadsheet, saved it as a CSV file, and then I uploaded it to the Vital program. So when I ran it, you have you have two balls. There's actually two balls there, blue and an orange, and they're both oscillating in this system, and you can tell that they're different rates, like they're not exactly touching. And that's because, just for example, one thing, in the model there's no loss of energy, but in real life there's energy loss due to heat, friction, just like different components that will eventually slow down your system. So in our program, up here, here's my kinetic energies, my gravitational potential, spring potential, blah blah blah, delta E, and so this delta E is actually going to equal 0. So when we run this program, you'll see that it's oscillating over here, and so this is like kinetic energy, gravitational potential, spring potential, something, and then this blue is one of the energies too. And then there's also a yellow line down here that is actually equal to 0 because all these forces cancel out. So that is showing that the law of conservation is conserved, and that physics is actually right in this case. So yeah, so like I said, the periods of oscillation in the X direction and the Y direction are not actually the same, because the forces acting on the spring in those two different directions don't relate at all. They're just completely separate. So I found that the period of oscillation, so this one is for the video that we tracked in Tracker, along with this one. These are the actual values, and the model these are the two model values. So they were pretty close to each other. This one was like almost exactly the same. So that's the period for the X direction, and this is the period for the Y direction. Like I said, it's because the reason that they're different is because the motion in those two directions is not related at all. Like, if you throw a ball into the air, the X direction, it's going to move the same, it's going to have the same velocity in the X direction the entire time, but when you throw it, its Y direction, it's going to start out with a high Y velocity, and then it's slowly just going to go down and down and down till its peak when it's 0, and then it's going to start turning negative. So oh my goodness. So it's the same thing in this case. They're not related at all. They just kind of do their own thing. So And also for the what does it mean, number 2 is the energy principle satisfied. And yes, like we said, since this is a closed system and no work is being done on the system, these are the 3 components right here of energy that are actually involved in the system, and they all cancel out to equal 0. So it is the energy principle is satisfied. Also, for if you change the location of the origin, it would not change whether or not the energy principle was satisfied or not. It would only change possibly like the sign of your different energies. So say that, like, well, here we'll go to tracker so you can see this better. Say we change the origin from here to down here. That would just change the sign of your potential energy. So the potential gravitational energy would be negative, and the potential spring energy would be positive. So honestly, it doesn't matter where you put the origin. It'll just change the sign of your different energies. So they'll still cancel out because it's changing the sign of all of your forces, of all of your energies. If it only changed one, then it wouldn't work, obviously. But if you change the sign to all your energies, they'll still cancel out to equal 0, no matter how you change that. So when I run this code, you'll see here, these are the x positions as it oscillates, and these are the y positions as it oscillates. And you can tell that through here, they're not oscillating at the same rate. Like, these peaks and these valleys don't line up exactly correctly. Like, it's pretty much completely separate. So that's a big point. They oscillate at different times, like I said.